Yes, good morning. We are going to start today the next aspect of the topic metals, semiconductors, and superconductors. Yesterday, we have seen the physical properties which are responsible for the different characteristic features of metals. In this regard, I would like to show you some PowerPoint presentation so that it will be more useful for your further studies. Just see this PowerPoint presentation. Now, if we look at the different physical properties, that is distinctive properties that we already discussed yesterday, that here the blue colored portion that indicates these are all metals. So most of the elements from the periodic table are the metals. Now, these are the metals. This is aluminum, this is a silver, gold, this is iron, this is again iron, this is again stainless steel, and this is iron. So, everywhere we can find that the use of metals is essential. Yesterday, we have discussed these properties such as malleability, ductility, hardness, metallic luster, the thermal and electrical conductivity, and the sonority. So, in brief, we are going to see all these properties. The malleability, that means one can give the shape by hammering. So, here the metals can be beaten into thin sheets by hammering. That property is known as a malleability. Then gold is the most malleable metal. Here it is estimated that 1 gram of gold can be beaten into sheets with an area about 6.7 square feet. That means this ductility, these metals can be brought into wires. That property is known as the ductility. Here, the ductility property is utilized in the filament of electric bulb, which is made up of the fine wires of tungsten. And when tungsten is electrically heated, it glows, and hence we can observe the light. Again, platinum is the most ductile metal. Copper, gold, etc. These are also used as thin wires. That means again a ductility. Here, this is ornament which is made up of the platinum, which is costlier than gold. Then 1 gram of gold can be drawn into wire of about 2 kilometers in length. So such a ductile property that is exhibited by the metal such as gold. Then the property that is known as a hardness. Hardness is another property of metal. However, there are quite few metals which are very soft. Sodium, lithium, gallium, cesium, and potassium. These are rather soft metals. Then the metallic luster that we have already observed yesterday, that it is a property, that is when the surface of a metal that appears a shiny, that property is known as a luster. It is because of the excitation of electrons to high energy and again jumping back to the ground state, during which they emit a light of all wavelength, and hence we observe the shining appearance of the metal, which is known as a luster. Then the thermal conductivity, the ability to conduct heat is an important property of metal, and this is directly related to the number of valence electrons which are present in the metal. Then silver is the best thermal conductor amongst the metal. Aluminum, copper, etc. also possess comparatively high thermal conductivity. Hence, as we know that most of the electrical wires, they contain either copper or aluminum. But as compared to the cost of copper, aluminum is rather cheaper. Hence, sometimes aluminum metal may be used as a good conductor of electricity. Here, these are the electrical wires which are made up of the copper. Copper is a good conductor of electricity. Yesterday, I have discussed about the sonority. That means these certain metals, they can produce a specific sound. So when they hit to a hard, or they stuck to a hard surface, they produce a specific sound. And I have given you the example that the bell that is in the temple, or this is a school bell, he's ringing this bell, or these are also uh, having the sonority property. So the production of specific sound, that property is exhibited by the metals, that is known as a sonority. Metals can also be used for making electric wires, aluminum foils to wrap food materials. For example, the food that is given in the trains, long distance trains, the food is wrapped in aluminum, which keeps the food rather hot for a very long period of time. The utensils which are used in the kitchens, those are also made up of this aluminum. The farming tools, the various tools which are used by farmers, these are also made up of iron. The bells used in places of worship, that is in temple, that is it is because of the brass material which is made up of copper and zinc. So this is how we have seen the different properties of the metals which are associated. So these distinctive properties, they lead to all these parameters. Today we are going to study a very important theory, that is theory of bonding in metals. Two theories were put forward. The first theory, that is known as a free electron theory, or it is also known as a electron gas theory or electron sea theory, and second theory, that is known as the band theory. Today we are going to study a very simple theory, that is known as the free electron theory. The name itself suggests that there must be presence of free electrons in the metals, and because of which the word that is given as a free electron theory. The theory itself was proposed in the year 1900 by Drude, but later on the theory was refined by another scientist, that is known as Lorentz, in the year 1932. The theory is also sometimes referred as a Drude-Lorentz theory, or simply the electron gas theory or electron sea theory. So the theory that is referred as electron gas theory or Drude-Lorentz theory, which is first of all proposed in the year 1900 by Drude and later on refined by Lorentz in the year 1933. Only two assumptions were given by these scientists. The first assumption is that, in fact, these metals contain free electrons. Plenty of free electrons are there. And according to this theory, there is not at all a repulsion takes place in the electrons, because electrons are negatively charged particles. Whenever there is a crowding of the similar charges, definitely there must be repulsion. But this theory tells us that there is a not at all repulsion of these electrons, because according to this theory, the electrons are symmetrically distributed, or the electrons are delocalized. That means spreading of electron density equal over all the atoms which are present in the metal. And because the spreading of electrons, that is known as a delocalization. So because of delocalization, there is no repulsion as such, and this particular fact is proved by this free electron theory. The second assumption that is given by Drude and Lorentz is that the metals are having the same potential throughout the crystal. That means if we consider any particular crystal, then it is having a same potential across the crystal. Now, if we look at some part of this theory, then we can see the theory that is known as the free electron theory. This theory was proposed by Drude and Lorentz. Drude proposed in the year 1900, and later on it was refined by Lorentz in the year 1932. So here, according to this theory, say for example, if we consider this is a piece of metal which contains positive charged metal ions like this, also it contains the mobile electrons or movable, plenty of movable electrons are there. As we know that metals are having very low values of ionization potential. What is this ionization potential? The ionization potential, the ionization potential can be defined as it is the amount of energy that is required to remove an electron from an isolated gaseous atom. This is known as the ionization potential or ionization energy. For example, if we consider the electronic configuration of sodium, atom number 11, it is having the electron configuration as 2H1. Now, if we want to remove the single electron, then certain amount of energy is to be supplied so as to remove this electron. This energy that is required to remove this electron is known as ionization potential or ionization energy. As we know that metals have very low values of ionization potential. When the metal loses one electron, they become positively charged species because of loss of this electron. So these metals, they loses their electrons and become positively charged species. The electrons thus removed by every metallic element that is positive charged species, these electrons do not pertains to only one nuclei, but these electrons now move randomly like this. So if we want to show in some different manner, then one can also show. I am having the PowerPoint presentation of this particular fact, where these are the electrons which are released by the metal atoms. So these electrons are delocalized. That means these electrons are equally spread over all the positive atoms, and because of which there is a no repulsive forces existing between the different electrons. Now these electrons from which the metal from which the electrons are removed, these are known as the kernels. So the kernel is nothing but because of the loss of electrons when takes place, they form a positively charged species. This is known as kernel, or it is also known as a metallic kernel. So in this case, the electrons which are released by the metal atoms are not stationary. That means they are not confined only to one atom, but they spread to a greater extent to all the atoms which are present. That is, all the positive atoms, those are present in the metallic crystal. It is also seen that the outer electrons are then in a position to move not just around one atom but also around and in between the atoms. So when these electrons are moving like this, one another diagrammatic representation that I would like to show, that the outer electrons here, these are the outer electrons. The outer electrons, they also merge into one another, and there is no repulsion as such. So these electrons are mobile or delocalized. So according to this theory, the force of attraction between the positive metal ions and the negative electrons, there are electrons are present. So this force of attraction that existing between positive metal ions, that is metallic kernels, and negative electrons is known as the metallic bond. So the bond that exists in metals, that is known as a metallic bond. Now I would like to show you the PowerPoint presentation with regard to this. The diagram that I have drawn just now here, This is nothing but these are the positively charged metal ions which are surrounded by these mobile or movable electrons. When a positive metal ion loses the electrons because of low ionization potential, then the positively charged species is formed. This positively charged species is known as the metallic kernel. Now, here, when all the positive metal ions they loses their valence electrons, then these electrons they are delocalized over all the atoms. So, number of or plenty of electrons are there. This is known as an electron cloud or electron gas. As plenty of electrons are there, hence a particular word that is used is a sea of electron. Perhaps you might be knowing sea is nothing but plenty of water is there, and hence the similar type of word that is used, that is a sea of electrons. That means plenty of electrons are there, and when these electrons are delocalized over all the atoms, then they merge, outer electrons they merge into one another. So here I have shown the merging of the outer electrons, and this is an ion core. So the it is also known as electron pool or sea of electron or electron gas or electron cloud. So there always exists a force of attraction between positive metal ions and the surrounding mobile electrons also, and because of which the bond that is formed. Now if we see the theory, that is assumption that just now I have discussed, that this free electron theory was proposed by Drude in the year 1900, and further it is refined by Lorentz in the year 1932. The first assumption, only two assumptions were given by this theory, that the mutual repulsion between the electrons is absent because the delocalized electrons or the electrons are delocalized over all the atoms equally. That is known as a delocalization of electrons. Secondly, the potential, that potential field that is due to the positive ions, that means after loss of electrons, is completely uniform throughout the metallic crystal. Now, as just now we have discussed, the metals become positively charged species because these metals have very low values of ionization potential, hence they can lose the electrons very easily. Then the metals which loses these valence electrons means those electrons which are present in the outer shell, they become electropositive because of loss of electrons, and these freed electrons or free electrons which are lost by the metal are not bound with the single nucleus. That means if a single nucleus that releases or that loses the electron, that electron thus released does not pertains to the same atom, but it is spread out around the several nuclei, or other nuclei, those are also surrounded by this electron. Then these electrons thus lost or these freed electrons are referred as a delocalized, and the total collection is called electron cloud, or it is also known as electron gas, or plenty of electrons are there, hence a particular word that has been used is a sea of electrons. So just now I have mentioned that the metallic bond is nothing but it is the force of attraction between the positive metal ions and the electrons. Now this is all about the free electron theory of metals. I would like to give you one example so that you will come to know how the theory works. I would like to give you one best known example of lithium atom. Now, you have to listen very carefully for the better understanding of this free electron theory. Now, if we consider a lithium atom having atomic number 3, atomic number 3, the electronic configuration is 1s2, 2s2 and 2p1. In terms of box diagram, if we want to represent, then we can represent this as like this. This is 1s2, 2s2, sorry, this is 1s2 and 2s1, only 3 electrons are there. So this is 1s orbital, this is 2s orbital, while 2p orbital is empty. Now here the 2s and 2p, this is known as the valence shell of lithium atom. So how many orbitals are there? First orbital, second orbital, third orbital, and fourth orbital. So there are four orbitals which are present in the valence shell of every lithium. We have yesterday seen, while studying the first property, that is crystal structure, where we have shown a crystal structure for lithium sodium as like this. This crystal structure is referred as the body-centered cubic, and this particular structure is exhibited by lithium also. What is a body-centered cubic structure? Where one lithium atom is present at the center, which is again surrounded by 8 lithium atoms like this. These are the 8 lithium atoms. Why? It is surrounded by 8 lithium atoms because a perfect cube has 8 corners and one lithium atom is present at the center of this body. Hence, it is known as a body-centered cubic structure for lithium. Now, by considering the body-centered cubic structure of lithium, this is a central metal atom which is surrounded by in all 8 lithium atoms which are shown here. Now, this lithium atom having the electron configuration as 1s2, 2s1. So, this electron is lost by this lithium. So, every lithium will lost its one electron like this. So total loss of electrons by the central atom or central lithium atom that loses one its 2s electron, and all the corner lithium atoms, the lithium atoms which are present at the corner, these are 8 in number. So 8 electrons are again lost by these lithium atoms. So total number of electrons which are lost by this crystal is a 9. That means a central plus lithium atom loses its 2 electron. It is showing 10 minutes are left. So the central lithium atom loses its single electron, and all the 4 lithium atoms surrounded by this lithium atom are 8. So they can also lose their 8 electrons. So because of which the central plus lithium atom is in contact with 8 other surrounding lithium atoms, hence the coordination number is 8. So the central plus lithium atom plus surrounding 8 lithium atoms, they totally contribute in all, or there are 9 surrounding electrons, or those electrons which are freed by this lithium atom are 9 in number. So every lithium atom has in all 4 orbitals, which are those: the valence shell containing the 2s and 2p, the 2s orbital and the 2p orbital. 2s containing only one electron, 2s1, while 2p is empty. So this is first, second, third, and fourth. So 9 electrons from the body-centered cubic structure, they are having 4 valence shell orbitals. That means 9 multiplied by 4, there are in all 36 orbitals. There is a choice of this single electron is having the choice of 36 orbitals. So this is how the 36 orbitals forming one unit cell of lithium atom. So because this central plus lithium is in contact with 8 surrounding lithium atoms, hence the coordination number is 8. That means the central plus lithium atom is in contact with 8 surrounding lithium atoms. So the coordination number is 8. So central plus lithium atom loses one electron, and surrounding 8 lithium atoms, they also loses their electrons. So 9 electrons are there, and these 9 electrons have in all 4 different orbitals. So 9 multiplied by 4, that means there are 36 orbitals. So these single electrons which are released by every lithium has in all 36 orbitals over which these electrons are delocalized. That means this is known as a sea of electrons or electron cloud or electron gas. Thus, the 9 electrons of lithium atom have freedom to move simultaneously in all these 36 orbitals. Since the theory accounts for the sea of mobile electrons because plenty of electrons are there in metallic crystal, it can successfully accounts the different property that we have already explained, such as the malleability, ductility, the metallic luster, high electrical conductivity, thermal conductivity. So all these properties are successfully explained by this particular theory. So the only drawback of this theory is that the theory does not give any idea about the semiconducting properties of lithium atoms. So this is the only drawback. So in order to overcome this particular drawback which is arised in this theory, another theory was put forward. That theory is known as the band theory of metal. So this is how we can see that the metallic elements, they loses electrons and they form the sea of electrons, and the electrons thus released, these electrons are delocalized over all the atoms. So the concept is rather difficult to understand, but you should remember that in case of lithium, it is having a body centered cubic structure where one lithium atom is present at the center, which is surrounded by 8 lithium atoms. Every lithium loses its 2s1 electron, and the electrons thus released by every lithium atom, that means 9 lithium atoms are there, which is a very small part of this lithium crystal. All these electrons thus released do not pertain to any one particular lithium atom, but these electrons thus freed or thus released, they are spreading over all the lithium atoms equally. That is known as a delocalization. So plenty of electrons are there. This is known as a sea of electrons, and this is how the theory can be explained. So 9 electrons which are released by only one piece of this crystal, that is having 36 orbitals, that is 1 2s and 3 2p, that is 2px 2py and 2pz 2pz. So every lithium atom has 4 valence orbitals which constitute what is known as a valence shell. So in all 36 orbitals are available, which is surrounded by these electrons. So this is how this theory that is proposed by Drude and Lorentz in the year 1900 and in the year 1932. So the theory that was put forward in the year 1932, that is a refined part of this theory. Hence the theory is known as Drude-Lorentz theory. So the theory that is very important from the examination point of view. So you have to explain this theory by taking into account the best known example of lithium. So lithium is having low value of ionization potential. So very lesser amount of energy that is required to remove an electron from this lithium atom. That means it is having low value of ionization potential. Now